myself Ravikumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the concept of transformed network. That is, if the given circuit or the given network consists of R, L, C elements. That is, the given circuit is having resistance, inductance, and capacitance. Then, for the three elements, you have to apply Laplace transformation. All elements should be changed into the Laplace transformed elements. Then, after applying Laplace transform element, the change in network, that network is called as transformed network. When the given elements should be changed into the Laplace transformed elements, then that network should be called as the transformed network. Then after changing into transformed network, then you have to apply KVL or KCL. Then the given network should be changed into the standard equations of the two-port network parameters. Then find out the required parameters after changing into the transformed network. That is how the elements are to be changed into transformed. That is, if the circuit consists of resistance, then it is constant value. Then after changing into Laplace transform, LT is Laplace transform, then the element should be changed into R. After changing into Laplace also, it is R. It is a constant value. And if the circuit consists of inductance, then you can apply Laplace transformation to the inductor. It is a single derivative. For single derivative, we have in S term. Okay, that is the single derivative Laplace transformation is S. Then it is having L coefficient. That's why S into L. Similarly, for capacitance, you have to apply Laplace transformation. It is a integration part. Then for integration part, the Laplace transformation is 1 by S. That's why the quotient is 1 by Cs. Okay, this is the Laplace transformation of the elements R, L, C. For R, the Laplace transformed is R. For L, the Laplace transformation is S into L. For capacitance, the Laplace transformation is 1 by Cs. Then, if the circuit is impedance, then for resistance, it is also R. Suppose it is inductance, the impedance is S into L. For capacitance, the impedance is 1 by Cs. That is, all elements are we have to calculate it in the form of impedance, or all the elements we have to calculate it in the form of admittance. That is, suppose it is element is admittance, then the term should be changed to G. G nothing but conductance, that is 1 by R. Suppose for inductance, it is reverse 1 by SL. For capacitance, it is 1 by Cs. Then it will be changed into C into S when all elements are calculated in impedance form. Okay, these are the transformed elements in the form of impedance as well as in the form of admittance. Then you have to verify, you have to calculate the two-port network parameters by taking simple example here. I am taking, consider the circuit here. Then consider the circuit, find out Z parameters. Then the circuit consists of resistances and inductances. In the circuit, there is no capacitance value. Then what is our first step here? For the given circuit, that circuit should be changed into the transformer network. Then resistance, inductance, apply Laplace transformation. These are the standard equations of Z parameters. If you have derived the equations in terms of V1 and V2 equations or in terms of I1, I2 equations. Then compare that you have derived Z11, Z12, Z21 and Z22. Okay. Then apply Laplace transformation to the given circuit. Then how the circuit is changes. The resistances and resistance and inductance, and second element also inductance. Then here two port, that is V2. For V2 the current is I2, and this is V1. For V1 the current is I1. Okay, here the element value is given 1 ohm. That's why for resistance apply Laplace transformation, it is R. That's why 1. For inductance apply Laplace transformation. For inductance S into L. Okay, in the circuit L value is 1. That's why S into 1 it is S. Similarly, second element also S. Then this network is called the transformed network. Why? Because all elements in the form of Laplace transformation element, that is in the form of S. Okay. For this circuit, you have to calculate the required parameters. Okay. That is, I am considering the loop current. First loop is I1, second loop is I, and third loop is I2. Okay, I1, I2. Already we know the directions of I1, I2. You can take the same directions of I1 and I2. Then what is the first step here? Apply KVL in the to the first loop. Okay, observe here the first loop consists of two elements, 1 and S. That's why the drop across 1 is, that is equal to I into R. That is I1 into 1. Similarly, across S, that is I1 and I, both currents are passing through S. Then the drop is I1 minus I into S. Okay, na? That is the drop across S value. Why? Because I1, I2 both are flowing through reverse direction. I1 is this direction and I2 is this direction, passing through element S. Both are having reverse direction, and for second element I passing downwards and I2 also passing downwards. Okay, na? Then in the first case, I1 and I both are passing in reverse direction. Okay. Then apply KVL to the first loop. That is the source I1 is passing from minus to plus high potential. That's why V1 equal to 1 into I1. I1 plus I1 minus I into S. Then we have to simplify the equation. I1 plus S into I1. That is I1 will be common. That is 1 plus S into I1 minus S into I. This is considered equation 1. Similarly, in equation 2, we have three elements. Then there is no voltage source. That's why apply KVL to second loop. Okay, these are the first loop equation. These two. Then similarly, apply KVL to the second loop. For second loop, what equation here? Across 1 ohm, the drop is 1 into I plus, then for first S, the drop is I minus I1, both are reverse direction, and for second S, both currents are in same direction. That's why I plus I2. There is no voltage source. That's why equal to 0. You can simplify the equations. Minus S into I1 plus S into I2. Then 1 plus S plus S. that is 1 plus 2s into I equal to 0. Then from this, you have to find out the value of I. We don't know, we don't require the value of I. We can require the values of V1 and V2 in terms of I1, I2. That's why you have to eliminate the value of I here. That means 1 plus 2s into I equal to s into I1 minus s into I2. From that, the value of I is s by 1 plus 2s into I1 minus s by 1 plus 2s into I2. This is equation 2. Then similarly, these equations are belongs to the after applying KVL, that is for second loop. Similarly, apply KVL to third loop, then the circuit only we have in the third loop only S element is there. Then apply KVL to the third loop. What is the third loop? Equation that is V2. Then the current I2 is passing from minus 2 plus higher potential. That's why positive V2. Then only element is S. Both currents are passing in the same direction. That's why V2 equal to S into I2 plus S into I. This equation consider third equation. Then both equation 1, equation 3, both are in the form of I. Then you have to eliminate the value of I here. That means replace the value of I in equation 1. What is equation 1 here? That is V1 value. 1 plus S into I1 that is V1 equal to 1 plus S into I1 minus S into I. What is I value here? S by 1 plus 2S into I1 minus S by 1 plus 2S I2. Okay, this is the value of I here. Then simplify the equation 1 plus S into I1, then S square by 1 plus 2S into I1 minus minus plus S square by 1 plus 2S into I2. Then I1 will be common here. In the above equation, I1 will be common. That is, take LCM 1 plus S, 1 plus 2S minus S square by 1 plus 2S into I1 plus S square by 1 plus 2S into I2. Then here simplify the numerator value. That equal to 1 into 1 plus 2S plus S plus 2S square minus S square by 1 plus 2S into I1 by 1 plus 2S into I2. Then 2S square minus S square. Then 2S plus into 2S plus S. That is the equation is S square plus 3S plus 1 by 1 plus 2s into I1 plus s square by 1 plus 2s into I2. So this is the V1 value. Okay, this equation you have to compare with standard equation of Z parameters. That is V1 equal to Z11 I1 plus Z12 I2. Then what is the value of Z11 is s square plus 3s plus 1 by 1 plus 2s. Similarly, the value of Z21 is s square by 1 plus 2s. Okay, in this way, the same manner, we have to find out other two parameters of Z. Then, what is the next step here? Replace the value of I in equation 3. What is equation 3 here? V2 equal to S into I2 plus S into I. That is V2 equal to S into I2 plus S into I. What is the value of S here? The value of I. We know the value of I is equation 2. S by 1 plus 2s I1 minus S by 1 plus 2s into I2. Then we have to replace the value of I here. S by 1 plus 2s into I1 minus S by 1 plus 2s into I2. This is the value of I here. Then we have to simplify the equation. That is, the S value is I1 value coefficient S square by 1 plus 2s into I1, common I2 value, that is S minus S square by 1 plus 2s. So this is the coefficient of I2 after taking the common I2 here. First value S, second value is minus S square by 1 plus 2s here. Then take LCM for second term, that is first term is common. For second term, S plus 2s square minus S square by 1 plus 2s into I2. Then you can simplify the equation here. S square 1 plus 2s I1 plus 2s square minus S square, that is S square. The common is S into S plus 1 by 1 plus 2s into I2. So this is the V2 equation. This V2 equation you have to compare with standard value, that is Z21 I1 plus Z22 I2. Then the value of Z21 is S square by 1 plus 2s. The value of Z22 is S into S plus 1 by 1 plus 2s. That is, therefore, the Z parameters for the given circuit, given network in transformed elements, that is, in the form of a transformed network, then the values of Z11 is S square plus 3s plus 1 by 1 plus 2s, and Z21 is Z12 is S square by 1 plus 2s. Then the value of C is S square by 1 plus 2s, and S square plus S by 1 plus 2s. So this is the required Z parameters values in the form of Laplace transformed network. That is in the form of S. You observe here the value of, that is Z12 equal to Z21. Both cells are equal. Okay. This condition is satisfied. What does it mean here? The given network is reciprocal network. Okay. In this way, you have to find out the given network into transformed variables. That is, you have to apply Laplace transformation for every element or LC. Then after that, apply KVL or KCL. You can derive the equations in the form of standard equations of two-port network parameters. Then find out the required parameters based on S terms. That is the Laplace transformation terms. Please subscribe our channel and share to your friends.